is 16, A is 7. We still have the law of sines. Our complete set of information is A's. We have A and we have angle A. So I'm going to do that. And let's go for C, since we have the other side there. So setting up the law of sines. Plug in what you can. 7 would go in for A. 30 would go in for angle A. C is 16, and we do not know angle C. So that's what we're going to solve for. So cross multiply and get sine C by itself, and we have this. So the sine of C is 16 sine 30 all over 7. We have a sine of 1.14. This should set off a little alarm. If it doesn't, go ahead and try to find out what what angle C is. To do that, you would take the inverse sine of 1.14, and you would get a domain error. Remember, domain is what goes into a function, and domain error means you tried to put something into a function that can't be put into a function. And the sine only goes from -1 to +1. 1.14 is bigger than 1, so that's not valid. This doesn't make sense. Therefore, no triangle exists. In other words, no solution. Why no solution? Because we used the law of sines and we found that an angle had a sine that was outside the bounds. It was bigger than 1. That's not possible, so no triangle exists. How about a more interesting one? Have a triangle where A is 10, B is 16, and angle A is 30. So let's just draw some kind of really random triangle here. A is 30, that would make that 10. B is 16. We don't know C or angle B or angle C. It is an angle side side. So approach with caution. And let's set up the law of sines. Our complete set of information again is A. So I have A over sine A, and I have 16 for B. I have 10 over sine 30, 16 over sine B. Okay, that looks a little better. So cross multiplying, we have 16 sine 30 over 10 for the sine of B. So to calculate that, 16 sine 30 is 8 over 10 would be 0.8. So we have a sine of 0.8. That is less than 1. So it's cool. We can go on. The angle B is the angle whose sine is 0.8. So I need to do an inverse sine and find out what that angle is. And we have an angle of 53.13 degrees. Okay. In the example we did yesterday, we tested to see if its supplement is also a possibility for this particular triangle. The supplement of B would be 180 minus 53.13. 180 minus 53.13. We have 126.87. This is the supplement of B. 126.87 degrees. Angle A is already given as 30 degrees. And what happened in the first example we did was the supplement of what we found plus the given angle came up to be greater than 180, which is not possible. You can't have a triangle that has a sum of the angles bigger than 180, so there was not a second triangle. This one, though, when I add the supplement of the angle to the given angle, that would be A, I get 156.87. That's less than 180. That means that there's possibly two triangles here. Okay, so what I want to do is I want to split this up into two different problems. On one hand, I have this 30, 10, this is all the given information, plus I found angle B to be 53.13. So let's do 53.13. The third angle would be when I take those from 180. So I have 180, take away 53.13, and take away 30, and I'm left with a 96.87 degree angle. Okay, that's triangle 1. In triangle 2, still have this and this. This is all the given information. In the second triangle, I found that its supplement, 126.87, also worked. So I have an angle of 126.87 for B. And now what would C be? I don't know, we got to find out. It would be 180 minus 30, which is 150 minus 126.87. Rather small angle of 23.13. So this one problem has now become two triangles to solve, and we need to find side C for each one. And for that, you can use any of the combinations of law signs, like A to sine A is C to sine C, and solve it that way. For this one, we can do A to sine A, C to sine C. So that, let's kind of recap this one from the beginning. We were given a triangle. We saw it was angle side side, so we approached with caution. We set up the law of sines to find our first angle, like we went after sine B here. So we did that, and we found the sine of B was 0.8. That is less than 1, so we keep going. Well, what is angle B itself? We had to take inverse sine to find that the angle was 53.13. Okay. This angle has a sine of 0.8, but as we know from the work we did with the unit circle, the sine is the y-coordinate on the unit circle, and there are first and second quadrant angles that have the same y-coordinate on the edge of the circle. So we have to make sure that its complement, which also has a sine of 0.8, won't also make a triangle. So took the 53.13 from 180 to find its supplement. So the 126.87 is the supplement of B. Call that B prime. Does that make a valid triangle? Well, it has to not be so big that when you try to put it together with a 30-degree angle, you end up bigger than 180. So we added it to 30 up here to check, and we found 156 leaves room for a third angle to get us to 180. So that means there is a valid second triangle. Wow. In the first example we did, when we added those together, it came up to be greater than 180, so that meant no, its supplement does not form its own triangle. So once we found that it does form two triangles, I just drew, and these aren't drawn to any sort of scale whatsoever. You can see that the 126 should be very obtuse. But it's enough to lay out and get the information in order. That becomes two problems where